Alright, so on Friday, you should have written down all your theorems on your theorem sheet. So, if my lines are parallel, one of the theorems we have is corresponding angles theorem. That theorem says that if the lines are parallel, then corresponding angles are what? Congruent. Casey, give me one pair of corresponding angles that must be congruent to each other then. 1 and what?
5.
5, good. Okay, those have to be congruent to each other because they're corresponding angles and my lines are parallel. Emma, can you give me another pair, please?
2 and 6.
2 and 6. Now, are 2 and 6 going to have the same number of tick marks as 1 and 5?
No.
No, because these are a linear pair. They don't have to be equal, so I'm going to put 2 tick marks on those. Okay. Paul, give me another pair.
4 and 8.
4 and 8. How many tick marks are you going to put on those? Just 1, because 1 and 4 would be the same, right?
Yeah.
Okay, so I'm going to do just 1 on those. Good. Chesley, one more pair. 3 and 7. And those are going to have how many tick marks? 2. Good. Okay. So it looks kind of a mess on our diagram, but as we went through that, we named the 4 different pairs of corresponding angles that now must be congruent if the lines are parallel, correct? Okay. Like I said, I'm going to backtrack out of this, find a way to keep it organized on your paper, probably write the angles off to the side. The next one is our alternate interior angles. It says if alternate interior angles are congruent, then what? Or excuse me, if the lines are parallel, then alternate interior angles are congruent. I gave that one away. Kai, give me one pair of alternate interior angles, please. Alternate meaning opposite sides of transversal.
Oh, so like
3 and 6. Okay. Ukaya, give me another one.
1 and 4.
1 and 4?
No, it'd be 5 and 8.
Those are vertical angles.
4 and 5.
4 and 5. Are they going to have the same number of tick marks as 3 and 6?
No.
No. Okay, so 3 and 6, 4 and 5. Those are alternate interior angles. If the lines are parallel, they must be congruent to each other. Okay. The next one is the alternate. You with us? You good? Alternate exterior angles theorem. It says that if the lines are parallel, then alternate exterior angles are congruent. Bo, can you give me a pair of alternate exteriors?
1 and 8.
1 and 8. They must be congruent to each other if those lines are parallel. Dylan?
2 and 7.
2 and 7. They must be congruent to each other if the lines are parallel to each other. Okay. Questions on any of those so far? Okay. The last one is our consecutive interior angles theorem. And it tells us that if the lines are parallel, then consecutive interior angles are supplementary. Okay, that's the one where it seems like a trick because we're so used to things being congruent. Vertical angles congruent, corresponding congruent, alternate interior congruent, alternate exterior congruent. Consecutive interior though are supplementary. So I just pointed at them, so I'm going to go ahead and write those ones. Angle 3 plus angle 5 must equal 180 degrees. Sophia, what's my other pair?
4 and 6.
4 and 6, good. Angle 4 plus angle 6 has to equal 180 degrees. Okay. Hopefully those aren't too difficult for you. You will always have your theorem sheet available, right?
Yeah.
Okay, so that shouldn't be an issue on figuring out what's congruent to what with that available to you. So, I just have 3 examples I want to do with you, and then you can have the rest of the class to work on your assignment. I'm going to need the right button though. Okay, so the diagram that I have here that's in the wrong place actually. That's supposed to be here. That's 2x degrees, this is 120 degrees. I'm going to go ahead and mark these as parallel because they're supposed to be. Is that important that those are parallel?
Yes.
Yes.
For any of these theorems to work, those lines have to be parallel to each other, correct?
Mm-hmm.
Okay, so if I go back to what we did last class period or last lesson, can I say that any of these angles are congruent besides vertical angles? Can I use the corresponding angles theorem or the alternate interior angles theorem? No, because I don't know that these 2 lines are parallel. As a matter of fact, they look like they're not. Okay, so I can't use these theorems that we're now talking about. The lines have to be parallel for these theorems to work. Now the other catch with this specific problem is, do I have any of those angle relationships between those 2 angles labeled that we've talked about? Are they corresponding? No. Are they alternate interior? No. Alternate exterior? No. Consecutive interior? No. Okay, so what I have to do now is I have to find a different angle measure that has one of those relationships with my 2x. Okay, you have all sorts of different options for this. Okay, I could use vertical angles and find this angle, and then these would be, they'd be supplementary because they could be consecutive interior angles, right? So I could do that. Or I could do a linear pair here, and these 2 angles would be alternate interior. Or I could do these 2 angles linear pair, and these would be corresponding. Or I could do corresponding angles here with 120 in this angle, and these would be a linear pair. Or I could do alternate exterior with these 2, and these would be a linear pair again. Okay, so there's all sorts of different things I could do, right?
Yeah.
Is one going to be more right than another?
No.
No, you should get the same answer anywhere you go. Personally, I like alternate interior angles. I have no reason as to why, it's just the one I like the most. Okay, so I would find this angle. Well, these are a linear pair, this must be how many degrees? 60, because they have to add to 180, right?
So x equals
So now, the equation I would set up is,
2x plus 120 equals 180.
or I could just do 2x equals
Oh,
60, right? And x equals
30.
30. Now, the reason I'm setting up that equation, I know you might not always have to, you might be able to do some of it in your head, but does the ability to do it in your head change if I start doing this? And now I gotta set those equal to each other. That ability changes, right? Okay, so make sure you understand and could set up an equation if you had to. Okay, I know that math 2x equals 60 is not very hard, probably do it in your head, but make sure you understand the equation you would have to set up if needed. Okay. Next problem. tells me my lines are parallel. And they give me 6y minus 3 degrees and 129 degrees down here. Now, just in terms of initial setup, is this one going to be easier or more difficult to set up right away than the other one?
Probably more difficult.
I heard some of you say more difficult, some of you say easier. Who said easier? Why, William?
Oh, because they're alternate exterior.
Yeah, so to me, I would say, now, it might be harder to solve because it's 6y minus 3 instead of just 2x. But to set up, it should be easier because those are already alternate exterior angles, right? They already have one of those relationships that we've talked about. What do you know about alternate exterior angles if the lines are parallel? They're equal to each other. They're congruent. So setup should be easier because you don't have to find any other angle measures. Okay, you can just take and set them equal to each other. Well, now I add 3. I get 6y equals 132. Y equals 22. Okay, so maybe it was harder, a little more difficult to solve towards the end, but hopefully the initial setup, the fact that they're alternate exteriors, made it easy to get set up. Okay. Right, the last example that I want to do is similar to your example 5. It is different, but it's close. And what they're telling me in this example is they say a balloonist sees a car at a 37-degree angle of depression from horizontal. In the diagram, angle 1 is 37. What is angle 2? Okay. So what they have here is they have a hot air balloon. Because of my artistic abilities, it looks like a light bulb. Okay. And they have a car, which does not look any better than my light bulb. Okay, but you guys get what's going on here, right?
Looks like a smart car.
Everybody keeps telling me it looks like a tractor.
It does.
It honestly looks like the skates.
Yeah, it looks like a roller skate.
Like a roller skate? Okay. It does look a lot more like a roller skate actually than anything. Anyways, what they're saying is that the angle of depression, which might be a new term for you, but an angle of depression is going down. Angle of elevation would be going up. Okay, you'll have to know those two differences. We'll use those words quite often. Okay, but it's always from horizontal. Okay, you're never going to talk about an angle of depression from anything other than straight horizontal. So, the angle of depression from here would be going this way, correct? That'd be depressing it, going down. So they tell me that the angle of depression from the balloon to the car is 37 degrees. Okay. Now you have to understand that that's always going to be the angle touching the horizontal side. Because I do get people confused and they say that this is 37 degrees. That's not an angle of depression because neither of these sides are horizontal. Okay? Your angle of depression has to have a horizontal side. Same with your angle of elevation. Your angle of elevation would start perfectly horizontal, but then go up. That's an angle of elevation. So this would be the angle of elevation, correct? Okay. So what the question is, and what they have labeled as angles 1 and 2, they want to know what is the relationship between the angle of depression looking down from the balloon compared to the angle of elevation looking up from the car. They should be alternate interior angles, right? Okay, so this angle must be 37 degrees. Now, they never told you that those two dashed lines were parallel, correct? But I told you that to have an angle of depression or elevation, you have to be basing it off of a perfectly horizontal line, correct? So would those lines be parallel? Yes. Okay. If they were not parallel, this wouldn't work, correct? Okay. So just some new terminology there for you. Okay, you will have problems like that in your assignment and on future quizzes and tests, so be aware of that. Any questions before you start your assignment?